So today we're going to talk about solving systems with matrices or solving systems by matrix. Matrix is a singular version of the word matrices, which is the plural version of it. So this is just another way. They're solving by graphing, substitution, elimination, and matrix is very, very similar to elimination. So what is a matrix? A matrix is just an array of quantities. It's just row by column. So an array of quantities just means a group of numbers, and like I said, it's always row by column. So if I talk about a matrix that's 3 by 2, that means I have 3 rows and 2 columns with numbers. Okay. A coefficient matrix is a matrix with just coefficients of a system. And I'm going to show you examples of all of these in just a little bit. So coefficient matrix is a matrix with the coefficients of a system. Remember, the coefficient is your number in front of the variable. The constant is the one with no variable, but your coefficient is just your number in front of your variable. An augmented matrix is essentially whenever you take two matrices and you combine them so you get one matrix. So for example, you could just write, it's kind of like a little combo. That's not really the math definition, but basically it's going to be our matrix with the coefficients and the solution. So it's taking the coefficient matrix and the solution matrix and combining them. So before we talk about Gauss-Jordan elimination, Gaussian elimination, and reduced row echelon form, which I know all of these words can look a little bit scary, let's just look at these examples down here of matrices. So this matrix right here, matrix A, has 2 rows, 3 columns. Remember, rows go this way, they're horizontal. Columns go this way. Just think like you row a river is horizontal, however you want to remember it. So this right here is a matrix. This is a row by column, 2 rows, 3 columns. So this is a 2 by 3 matrix. And that's how I would say name it. Matrix B has 3 rows, 4 columns. So this is a 3 by 4 matrix. This matrix right here, 3 rows, 3 columns. So it's 3 by 3. This matrix has 3 rows, 4 columns, so 3 by 4. And then this one, once again, 3 rows, 4 columns, so this is 3 by 4 again. Okay, augmented matrices usually will have this little symbol right here, that bar. That's just saying that this is my coefficient part, and then these are my solutions. So part B over here, matrix B, this is also, there's my coefficient part, there's my solutions. And you don't have to highlight this. We're going to do lots more examples. This right here is just a coefficient matrix. I don't have that bar with the solutions. So this one right here, this is just your coefficient matrix. And these were examples of augmented matrices. And this right here tells me it's a 2 by 2 system. That, with all those 9, that tells me it's a 3 by 3 system. Okay, over here, this is another example of an augmented matrix. You don't have to put that bar there. It makes it easier if it's there, but you don't have to put it there. So this is an example of an augmented matrix. This one over here is another example of a augmented matrix. Just without the bar. Okay, now, you don't need to stress out or like worry about getting lost in all of these vocabulary words. You just need to know that if it tells you write the augmented matrix, you need to put the coefficients and solutions. But if it just says write the coefficient matrix, then you just need to write the coefficients. And yet again, we're going to do some examples with these, so nothing to stress out about now. Okay, Gauss-Jordan elimination is whenever you solve a matrix and you put it in reduced row echelon form. Okay, so it's solving the matrix. Essentially, you put it in reduced row echelon form. Okay, reduced row echelon form for short is RREF. Gaussian elimination is when you put the matrix in row echelon form, not reduced row echelon form, but just in row echelon form. And instead of RREF, we call this REF for row echelon form. Okay. Reduced row echelon form is going to be more work than row echelon form. Row echelon form will just give you one variable. But if you're solving a system and you're solving for 3 variables, row echelon form isn't going to be very helpful because my goal is to try to get 3 by 3. I want to solve for all 3 variables. Now, what is reduced row echelon form? It's ones along the diagonal and zeros elsewhere. So zeros in the other spots. So it's ones on the diagonal and zeros above and below, essentially. Okay, yet again, I know this is a lot of vocabulary. Most of the time, you'll have the vocabulary where like it will just say write the coefficient, write the augmented, and you just have to remember what that means. So if I go back and I look at this right here, this one is in row echelon form. I have ones along the diagonal and I have some zeros underneath, but I don't have zeros everywhere that I'm supposed to have. So this is row echelon form. This matrix over here, I have ones along the diagonal, and I have zeros above and below. This is reduced row echelon form. Remember RREF for short. This is the one that you want. You want your matrices to look like this in the end. And we're going to work our way up to that. Okay. For now, you just need to know how to name a matrix, what a matrix is, how to find the specific terms in a matrix. So if I asked you to find element A sub 1, 3, sub just means it's lower. So A 1, 3, what that means is in matrix A, I need to find the number in the first row, third column. Remember, we always go row by column. So the first row, top row, third column. So number 8. That's it. Okay. Next one, in matrix B, I'm looking for the second row, fourth column. So second row, fourth column. That is 13. The next one, I'm looking at matrix C, row 3. I should have been a C. Column 2. So row 3, column 2 is 0. Okay. B1, 2 is now the top row. Second column, 6. And I'm going to give you a minute to try to do these last 3 on your own. Really check yourself here. and see what you get. And you could pause it if you're still working, but you should get that D row 4 column 2 is 0. A row 2 column 2 is 1. And then in E row 3 column 4 is 6. That's it. Okay. Now I have a system and I just want to write the coefficient matrix, which means that I'm just going to look at my coefficients and I'm going to put them in an array, a grouping of those quantities. So ask yourself, what are your coefficients? I have 2. That's technically a -1. And if there's nothing in front of it, that's just a 1. Then I have 3, 1, -2, 3, -1. And then there's no z, which would be a coefficient of 0. Remember, if you have 0z, that means that it's not there. So my coefficient matrix would be 2, -1, 1, just doing the coefficients. My second row would be 3, 1, -2. Remember that 1x or 1y is the same thing as x or y. And then my last row would be 3, -1. There is no z, 0. That's a coefficient matrix. That's it. I'm just writing my coefficients, just making sure that my x's are here, my y's are here, and my z's are here, and it all lines up. Okay. An augmented matrix now has my coefficients and my solutions. So my augmented matrix here would have my coefficients and my solutions. So my coefficient for the top row would be 6, and there's no y, so 0. I'm going to draw that bar, just means equals 11. And then my bottom row would be -3, 4, 2. That's it. I want you to try this next one. Pause it if you need to. And you should get 1, 1, 1, 3, 2, -1, 2, 6, 3, 2, -1, 13. And that's it. That's an augmented matrix. These are the ones that we use to solve, and we try to put them in reduced row echelon form to get our solution. But we're not there yet. Okay. On this one, now I'm going to go backwards. It says write the system. So I have a matrix, and it's always x, y, z equals, there's my answers. So the top row would be 2x plus 5y. There is no z, so I don't need to write 0z, just don't put it, equals 13. My next one would be -3x plus y plus 2z equals 6. The last one would be 4x, there is no y, minus 3z equals 5. And that's how I go from a matrix to a system of equations. Now, if you're still having trouble with this, you can go to Google and just type in like naming matrices or matrix vocabulary. In the next video, I'm going to jump in with how do you actually solve? How do you take this and put this into reduced row echelon form? And that process is called Gauss-Jordan elimination.